Okay, David, if you'd like to get us underway.
Hello, I'm David Shoemaker. I'd like to welcome you to this session. It's a sort of a metaphysics session. It's one that deals with things which are sort of one layer above actually making the data appear. And we've got talks from Kate Daniels, from Joey Key and Jeremy Wachter, Tuck Stebbins and Bernard Schutz, and then after a short break, we're going to hear from Jonah Canner. I do want to call your attention to the fact that the Q&A function is available. The questions that you type in there are visible to everybody. That's the best way to get questions to the speakers, which we'll take at the end of each one of the talks. So feel free to go ahead and put those in during the talk, and that way we'll get to you in some kind of order as we get toward the end. I think with that, I would like us to actually get going. The first speaker is Kate Daniel, University of Arizona, Steward University Observatory, who is going to talk about human challenges in large astronomy projects and collaborations. Kate.
Thank you so much. Let me get my screen sharing. There we go. Does that look okay? So thank you, David. It's a pleasure to be here. And thanks to the organizers of the symposium as well. Again, my name is Kate Daniel, and I am currently in transition from Bryn Mawr College to University of Arizona and Steward Observatory. I'm also Deputy Director and Director of Land and Community Partnerships for Cosmic Explorer, a ground-based or next generation ground-based gravitational wave facility that I hope everybody here is aware of. So to give you a sense of who I am, more broadly speaking, my research focuses on developing a theoretical framework for the evolution of spiral galaxies through dynamical processes. But today I'm here in the capacity to discuss a report from the panel on the state of the profession and societal impacts as a sort of an overview from of that report from the Astro 2020 decadal. So to give you a sense of what that means to date, the National Academies has performed 6 decadal surveys in astronomy. And while each of those has discussed the state of the profession and societal impacts, Astro 2020 was the first to feature a formal panel that is devoted to these concerns. So I was a member of that panel. It was a 15-person panel that participated in over 2 years of intense conversation to identify pathways to advance equity, diversity, and inclusion in the profession. So I do want to premise this by saying that in this talk, I will to some small degree discuss issues of sexual harassment and just racial discrimination. And I also need to just make everybody aware that I do not represent the National Academies or even the panel, but I'm here as an individual to report on, well, to talk about our report through my personal lens. So my hope is that a discussion of our findings can be fertile grounds for generative conversation, and in particular to gauge this and with a slant toward the ideas and topics as applicable to the LISA Consortium and our community more broadly. So, whoops. And again, before I even dive in, I do want to acknowledge that I am currently outside of Philadelphia, which is the ancestral lands of the Lenape. And I want to point everybody here to, as a global community, to this website. So it's nativeland.ca, and many of us occupy lands that are the traditional homelands of Indigenous people. So this website will lead you to, you can look up any place in the world, and it will give you a deeper sense of the history of those places and the people who were the ancestral stewards of those lands. So it's an incredibly, it's a wonderful website. It's a great place to get started. So I am going to be talking about the findings from the decadal survey, as I mentioned, and this is done by the National Academies, which is US based, but again, I think many of the concepts that I'll be talking about are more widely applicable, particularly in terms of the framework that we built in in the panel that I served on. So it's supported by NASA, NSF, and DOE. The survey is. This last year, it was actually also supported by the US Air Force. And our official charge for the report in its entirety as a review of the profession of astronomy and astrophysics was to provide an overview of the current state of astronomy and astrophysics, astrophysics science, and technology research in support of that science. So once we received much of the information that, in part was research, but in large part was informed from white papers that were submitted by the community at large, then we developed our charge was to develop a comprehensive research strategy to advance the frontiers of astronomy and astrophysics for the decadal period. One of the outcomes of the decadal was a strong endorsement of next generational gravitational wave experiments, for which we are all quite happy. But also was the report from the introspective panel, and that was the panel on the state of the profession and societal impacts. So in this talk, I'm going to overview 7 suggested goals and the frameworks that we use to reach those goals as outlined by this report. So that is specifically Appendix N in the decadal report. So these suggestions, the process was that these suggestions that we made in our report, which is Appendix N, were reviewed by the steering committee, who then made specific recommendations that were elevated to the final summary report. And our recommendations are in Section 3, if you're interested. I'm not going to discuss Section 3 of the decadal report, but rather I'm going to focus on our panel's findings. So, and that's because I think this is an excellent foundation for developing policies and practices and procedures that can lead to healthy cultures for scientific inquiry. And of course, being the first panel of its kind, the report from our panel was much more extensive than could be elevated in its entirety to the summary report. So I refer you to Appendix N for a concise set of comprehensive suggestions where we were really walking that line between concise and comprehensive. So I do want to just take a moment to recognize the people who served on this panel. There were 15 of us. Kevin Stassen was the liaison to the steering committee, so he wasn't technically a participant in the panel. Margaret Hansen and Enrico Ramirez Ruiz were the co-chairs for this panel. So the panel was incredibly diverse. It was an honor to serve with these people. There's representation from all over the place. Julie Passault is a social scientist. Rachel Ivey does statistics and data with AIP. There's representation from NSBP, NSHP, SACNAS, the Society of Indigenous Physicists, HBCUs, so historically Black colleges and universities. Jedidah Eisler is now advising the President Biden in the White House. There's a variety of folks from various institutions, academic, national labs, deans, chairs, project scientists, et cetera, representation from LGBTQ community, neurodivergent folks. So really it was an incredible experience. And I think every person on this panel would really agree. And what that meant was we were able to really talk around many issues from a multifaceted perspective. So we are, and especially during the time of this decadal, right, which was over 2019, 2020, 2021, was really in the midst of a moment of incredible social and environmental change. So the promise of the decadal survey was our collective power to not just respond to these environmental and social pressures, but to really influence our future. So the charge we were given was to make actionable suggestions on the topics of demographics, diversity and inclusion, workplace climate, workforce development, education, public outreach, and relevant areas of astronomy and public policy. So that is a lot. That was a lot. And what that meant was that we had to think of strategies in a sort of systems thinking framework in order to produce actionable suggestions that the community, that the profession, the community at large, could use in order to address these many charges. So systems thinkers have taught us that a system is a product of not just the sum of its parts, but also the interactions between its parts. So how do each of these components then interact with each other in our field, and where are the places that agencies or large collaborations and consortiums, or each one of us, what is the role that we can play? But in order to do that, we had to define the profession. So to be clear, the profession as we defined it is the community of scientists, engineers, technicians, and non-technical people that are engaged in the production and instruction of astronomical knowledge, as well as learners on the path to joining their ranks. So now that we know who we're talking about, we need an overarching goal to structure the report. And this is it, that the pursuit of science and scientific excellence is inseparable from the humans who animate it. So you'll notice throughout this talk that I may mention human capital, and that is really just a recognition that the people in the profession who do the science and their knowledge and skill sets are central to scientific advancement and are subject to inequities in the system in which that work is carried out. So there's plenty of work that has shown that diverse teams produce the best science. They're the most innovative, the most creative, and it's our ultimate goal to do the best science, in other words, scientific excellence. And if that is our goal, then it's simply not possible without equitable participation of the full diversity of the profession. So I'm not going to present on the deluge of evidence that there are systemic inequities that lead to inequitable participation in our field. These are entire fields of study. There are, in the report, Appendix N of the decadal, there are extensive citations that can get you started. If you're interested, I would refer you to that. I would also refer you to a summary that's in the landscape of the profession section of our report as just a place to begin. But what I am going to do is, under the assumption that these systemic inequities exist, then I'm going to talk through the framework that we used in order to build overarching interlocking goals in order to mitigate those inequities. So in order to do that, one of the first things we had to do was to make explicit the values and goals of the systems that we adhere to. So by explicitly stating our shared values, then we're able to assess merit of individuals and programmatics that advance those priorities. So when we have in any culture, right, and all of us exist within a culture, astronomy has a culture, we have a language that we use, acronyms that we're familiar with, for example, then there is an implicit value system, but as long as it's implicit, then it's subject to interpretation. And as such, inequities can thrive. So we wanted to build an explicit shared equity advancing value system that when we adhere to that and we recognize it explicitly, then that reduces ambiguity and provides avenues for accountability. So again, this is US based. This is true for really most funding agencies, but the founding documents of these agencies do have priorities that are based on an explicit value system. So when we looked at the founding documents for the federal agencies that we were being funded by, so that's NSF, the NASA, the DOE, then those explicit values were broadening participation, innovation, economic prosperity, and health and well-being. So funding agencies use those values to set funding prioritization. So why not the profession, right? Why not have the values, that set prioritizations for our profession, for any given collaboration like the LISA Consortium? And so we built a set of values for the community, meaning the profession, that can be shared values that are really mapped very well onto the values of our federal agencies. So we use those explicit values in order to articulate some of the suggestions that we made later on in the report. So quickly, broadening participation can be mapped onto equitable access. So what that is that a recognition that the profession, that members of the profession can contribute their unique talents and perspectives to the field while having fair use of all necessary and available resources. So for example, data would be one of those. Responsible stewardship maps very well onto economic prosperity, where the stewardship of resources and care really for those resources and consumption as they relate to people, processes and priorities in which they are situated. So for example, many of the resources that we use are an infrastructure that's built on indigenous lands. Multimodal expertise maps well into innovation. So multimodal expertise is actually, it's incredibly important, but I think oftentimes is one of the least appreciated. So what this is that in order for innovation, right, there are a variety of technical, individual, interpersonal, cultural, and systems thinking practices that are necessary to produce scientific excellence. So in the last decade, we've made great technological leaps and advances in pedagogical practices. But in order to cultivate a profession that's versatile and modernized, that means that we have to have the ability to respond and adapt to critical environmental and social and societal factors, as well as advancements in pedagogy and technology. I think accountability is probably one of the most widely recognized, and this maps well onto professional well-being. So this is just a clear articulation of thoughtful, rigorous, site-specific, but encompassing measures to protect those with the least power and thus foster equitable allocation of resources in our field. So what that means is, if we adopt those explicit values, then we have a framework that can help us set priorities and policies. So the recommendations that follow, that I'll talk about momentarily, are collectively intended to address the fact that the landscape of astronomy and astrophysics and physics also includes resource allocation and decision-making systems that privilege historically overrepresented groups at the expense of those who have been historically marginalized. And our profession, in my opinion, is more ready for this challenge than any other discipline of which I know. So LISA, for example, has a strong momentum for change. And as we've been learning, and we'll learn in the following talks, work is already underway. Next generation gravitational wave facilities are well poised to be leaders in innovating a more equitable systems of access and participation, and modernizing practices of our core structures. So those core structures, in other words, are the structures upon which our profession is based. So that would be mentoring, research funding, leadership, education, and community engagement. So our profession as a whole has a powerful tradition of organizing equity and inclusion, including affinity groups with AAS, for example, women in astronomy and inclusive astronomy movements. And with them in the last decade is a series of other organized efforts to assess areas where changes to policy and practice can create a more equitable profession. So, for example, the State of the Profession and Societal Impacts panel is, to my knowledge, the 4th or 5th set of recommendations in the last decade alone. So from this, now, 20 minutes in, we have an agenda where we have this dedicated collective of change agents, that's you, and core needs for the next decade are to include dedicated resources and effort towards systemic change management to enable the realization of these recommendations. So what are those suggestions? So first, we have an overarching goal for the report in its entirety, and that is to invigorate the profession through workplaces that reflect equity advancing values. And is there a typo there? Allow the full human diversity of our world. I changed it to our world instead of our nation, our world, to meaningfully and maximally contribute to the field. So, like I said, this includes interlocking systems and a multifaceted approach where each of the goals that I'm about to discuss, the 7 goals I'm about to discuss, depend upon each other, right? And they build upon each other. So these are to leverage funding structures, to recognize, motivate, and support, and hold accountable workplaces that are built on community values. To reimagine leadership in order to take advantage of the multimodal expertise of our full community, and using that relationship to end discrimination and harassment. To remove barriers to education and training to ensure equitable access to knowledge and full participation in the modernizing of practices of our profession. To partner with Indigenous communities to cultivate and sustain healthy relationships for mutual benefit, and to extend the partnership framework to nurture meaningful partnerships with our local and global communities in recognition that a truly inclusive astronomy is inseparable from every one of the spheres we inhabit. Now, in order to realize this ambitious program, we require that data collection in order to diagnose the current state of the profession and the places that we work, and inform new directions, and to assess progress. So now I'm going to go through quickly the 7 goals. You'll notice that each of these goals has multiple suggestions. You might notice that I begin with suggestion 3 or so, and that's just because I'm selecting a few of the suggestions that are most relevant for the LISA Consortium. Okay, goal 1. This was actually goal 0 for a very long time, really up until about the day that we submitted the final report. And that's because this is so very fundamental. And that is to collect and analyze demographic data wherever astronomy research, education, or training is conducted, and create internal agencies or society offices to review data and suggest policy change. So one of the things that we found is that there is a lack of consistent demographic data, and which inhibits our ability to evaluate our own progress, and really played an important role in this project, right? In forming this report. So the suggestion then is for agencies, but also collectives like the LISA Consortium, to collect, evaluate, and make available demographic data. And so This, though, I want to highlight, it goes beyond just demographics data, but also includes the lived experiences of the people who are in the profession, who are part of that collaboration, for example. So, and to do this in collaboration with sociologists, because sociologists can play a really critical role in the interpretation of those data. So the second is to use those data to document progress.
Kate,
Goal
five-ish minutes.
Excellent, thank you. So goal 2, we called leveraging power. So this is leveraging funding structures to expand diversity through inclusive workplaces and equitable practices. And I'd like to emphasize here, we say leveraging funding structures, but really this is leveraging any power that exists within the institution or structure within which you inhabit. So because this can be a multifaceted approach, right? Each of us holds power in different ways. So one of the things that we've come to learn is that a sense of belonging plays a critical role in aiding performance and retention and mitigating negative work climates. And this is particularly important for people from underrepresented populations. So, so the suggestion here is to adopt effective mentoring practices. So these are evidence-based practices, and that there are reporting systems to really hold those mentoring practices accountable. And the next is the teams that are leading. Most of our institutions don't reflect the diversity of the field. And this is really important, particularly for large collaborations and projects, to adopt evidence-based practices in order to allow the leadership to reflect the demographics of the field and the demographics of the world. So, and then of course, going back to data collection to be able to assess our own progress. Okay, goal 3 is reimagining leadership. So this is to develop, select, and sustain diverse cohorts of leaders who lead by exercising equity advancing values. And to give you a little perspective into what this means, the way we select and train and elevate leaders determines the advancement of our profession and the individuals within it. So when we train, there's a lack of early career leadership opportunities, which is a barrier to becoming a PI. The selection into leadership roles is also incredibly important, because this is the ability to lead and advocate for diverse teams is a requirement of a modernizing nation. So we need to address our selection processes. And then by empowerment, what we really mean here is to find means to sustain diverse leaders, particularly those from minoritized groups, and that requires a recognition of their efforts to advance equity advancing values. So, so in other words, we need to select future leaders with multimodal expertise who exercise equity advancing values. So that goes from the selection process all the way to career opportunities. And then we also need to recognize that oftentimes there's a disproportionate amount of labor on scientists who are who are members of the demographics of the very communities that we seek to better serve. So then what that means in terms of reimagining is to recognize their leadership in those areas in promotion, evaluation, et cetera. Okay, harassment and discrimination. So we need to establish clear policies to collect and report relevant metrics and enforce accountability measures to remove structures and individuals that perpetrate identity-based discrimination, including harassment. So cases of sexual harassment and race-based discrimination in the profession have already been covered in the media. It exists. And the fact that media outlets are covering these topics and highlighted as systemic and institutional failures means that there aren't supports for people in order to report these sorts of aggressions. So one of our suggestions is to recognize identity-based discrimination and harassment as research misconduct, as compromising scientific integrity. And then, of course, rather than it only being punitive, we also need to support those people by offering counter spaces and flexible funding that allow those folks to thrive. So goal 5 is to remove barriers, and this is modernizing practices that have disparate impact on access to education, training, and advancement. So this is one I see that I'm just going over time. We're almost there, but I do want to highlight this one in particular. So technical training programs in computational methods and instrumentation were identified as one of the major barriers for inclusion. And so at all levels. And so one of the suggestions is to provide opportunities for continual training in state-of-the-art techniques at all career levels, and to partner with underserved communities and institutions like primarily undergraduate institutions, minority-serving institutions, HBCUs, TCUs, so that's tribal community, tribal colleges and universities, historically women's colleges, et cetera, in order to mitigate those inequities. All right, last two. So cultivating local and global partnerships. This is to reframe policies around community engagement in order to embed cultural humility, ethical practice, and a growth mindset throughout the profession, and a continuous effort to cultivate and sustain healthy cultures for scientific inquiry. And this really begins with a reframing of outreach and broader impacts to be partnerships, so that in partnership with local and global communities that are actively engaged, ethically and respectfully engaged, then this builds community trust in science overall, and also allows for a means of benchmarks and outcomes to be identified that are done in collaboration with all people who have a stake in the project as a whole. And I'm over time, so I will just very quickly say that it is incredibly important that we recognize cultural identity as a strength rather than erasing it. This can be, this can be encoded in codes of conduct and training processes. We have a very important role in the mitigation of climate change and currently have a negative impact on the environment. And so the thing I want to highlight here is just that our profession plays a very particular role, and it's an important role in educating the public in the language of science, which has a snowball effect in terms of our elected officials and policymakers and our ability to communicate with the world at large. And then finally is to align the values of the profession with those of Indigenous and other local communities who are impacted by the profession, to cultivate and sustain healthy partnerships for the benefit of both. So the numbers of Indigenous folks in the profession are extremely low. And it is it is absolutely critical that we find ways to support Indigenous communities and to partner with them. So I will just move quickly through this and just say that culturally supported pathways for Indigenous people have been identified as incredibly important for their inclusion in the profession. And if you have an Indigenous student, please find ways to support them. I'm happy to have a conversation about that. And that as a collaboration, one way to really support the inclusion of Indigenous communities is to build networks and partnerships with Indigenous educational centers. So I will leave you with this, and that is that the pursuit of science, I just want to reiterate, and by extension, scientific excellence, is inseparable from the humans who animate it. That's us. And the goals that are stated here are no less worthy of our vigorous intellectual engagement and commitment than any of the other daunting problems that we pursue. And I'll stop there. Thank you.
Kate, thank you. Kate, thank you very much. It's clear that there's a great deal of thought that went into the report and this brief summary of it, and we could all spend some time studying these slides and understanding what really is behind them all. But you've given us a good introduction. Let's take a couple of questions. I see there's one in the Q&A box. I invite other people to add things here to the box. This is an interesting one. That in the LISA Consortium, there's no standing ombuds office since many years of its existence. What do you suggest to get this established? And actually, Kate, of course, is not as familiar with the LISA Consortium as some of the rest of us on the line here. And I'd like to break this question up into two parts. One part to be answered by Kate and the other part to be answered by our DEI chairs who are online here. Kate, what do you think of ombuds offices and the role of the ombudsperson? Is that something that has been shown to be something that's a successful and powerful technique to reach some of the goals that you've laid out here?
Yes, absolutely. And I think, but I also want to emphasize that it can't be the only resource, right? There have to be multiple means of support for folks throughout the consortium. So, and many of those are highlighted in the goals that I presented. Some of them are more deeply embedded in the suggestions that we made. But really for any real, so for an ombudsperson, I guess I'm assuming that the issues that we're talking about are something that are embedded in something that's a little more deep than an individual incident. Then that's oftentimes are rooted in systemic issues that are, go beyond the consortium, right? They're part of the world that we inhabit. And so in order to really address those questions and make sure that these, that the issues that are often brought to an ombudsperson are not repeated, right? Then there needs to be a larger structure for support and education and training around the sorts of issues that often arise in an ombuds office.
Thanks. I think probably what we'll do is allow the DEI folks to address this when their time comes up. I can also, okay, good, it's in the update. So let's then move on to the second question for you, which is, it reads as follows. It would be great to have such an analysis of the state of the profession for countries outside the US. What was the key argument that had the NSF to include the panel into the decadal review? So I guess the question is, how can we motivate this sort of study for a broader community or ones which are in the various different loci? Go ahead.
Right. So, I mean, it wasn't the NSF. It wasn't only the NSF. It was, so this is conducted by the National Academies of Sciences, and the profession of astronomy in support, supported by, meaning sponsored by NSF, NASA, DOE, and then this year, the Air Force, that is something that the community at large decided would be an important way to identify important goals for the decade and to really focus our efforts. So as far as including a panel for the state of the profession and societal impacts, there was an attempt in the last decadal to do that, although it didn't actually make it to the final stages. So I think, and this is really just coming from me, I think that one of the critical pressures that brought that particular panel to fruition was that there was a lot of motivation coming from the community to really begin to have these very difficult conversations. And the people who acted on that panel, I guess what I should say is that it was not through any small effort on our part.
In fact, we're going to have to wrap up questions soon. There's a follow-up that talks about the fact that most of your observations are rather US centric, or some of them are US centric is what I would say. And I think your answer makes it clear what we need to do is to have the organizational entities in Europe who pull together things like these sorts of reviews feel that pressure to have a very important panel to address these questions. One last question from YouTube, from Terry Brandt, regarding the importance of belonging for people coming into this profession, were there findings on belonging or lack for people already in the field, i.e. not students or early career folks? If not, what were they? Why not?
Oh, I'm looking through, I don't see that one. Okay, so could you say that question again? I'm not sure that I
of course. I'll read it again. So regarding the importance of belonging for people coming into the profession, were there findings on belonging for people already in the profession? People who have actually already made the investment, they've got a position, maybe they've got tenure or something. Do they feel that they belong?
Okay, so the sense of belonging for people who are already in the profession actually plays an incredibly critical role in retention. So there were many white papers submitted to our panel from people who had decided to leave the profession. And in fact, we had additional input from one or two folks who ultimately left the profession either at the time that the panel was doing the work of compiling a report, and also and you know, by the time it had actually been released. So it was actually incredibly evident to us that sense of belonging is something that that is really incredibly important for retention as well. And I think that one of the disservices that we do as a profession is we put quite a bit of effort into recruitment and outreach and other means of diversifying the profession from an initial perspective, but we don't put the same effort into supporting the folks who have already invested their time. And one of the points that I also want to highlight in reference to that is that oftentimes one of the means of survival, this is one of the findings, is that one of the means of survival for many of the people who are underrepresented is to do the work of equity, of EDI, right? And then because that work is not recognized and valued by the profession, particularly for promotion and tenure, for example, then those folks, they're in a catch-22, right? So they're doing the work that they need to do in order to change the environment so that they can find a sense of belonging and thrive. But by doing that very work, they are not receiving the recognition and promotion that they deserve for putting that work into the profession.
Oh, that's really a key observation. I'm afraid we're going to have to end there. There are a couple of other questions that are coming into the Q&A, and I think, Kate, you'll have a chance to take a look at those, I hope, as the meeting progresses. Thanks again, Kate. A stimulating, thought-provoking talk. Okay, good. Let us now move on to our second talk in this session. We're now going to have an update from the Diversity, Equity, and Inclusion team in the LISA Consortium. And we're going to hear from a combination of Joey Key and Jeremy Wachter, who are the two co-chairs, current co-chairs of the of the team. And I would like to invite them to go ahead and present.
Great, thank you. Thanks, David, for the introduction, and thanks very much, Kate, for the excellent presentation. Lots to think about and very, very relevant for our committee. So you may or may not know that the LISA Consortium has a Diversity, Equity, and Inclusion Committee. So we want to tell you a little bit about what we do. So the committee scope and activities broadly are to lead LISA Consortium diversity, equity, and inclusion efforts, and towards the goal of stimulating the growth of our inclusive culture in the consortium. So in practice, what that means is that we organize talks and activities for the LISA Consortium meetings and also for LISA Symposium meetings. So as we just heard, an excellent talk from Kate. We also do some internal work, consulting with other committees and groups on questions related to DEI. The working group chair nomination process, we often consult on. And then we have a liaison to the LISA social media team. And so the committee can provide liaisons to other committees and groups. We also propose new initiatives within the consortium. So this was the question about the Ombuds office. And so both Jeremy and David are working on establishing an Ombuds office within the LISA Consortium. So that was an excellent question. And then we also provide resources for the consortium. So there's a LISA Consortium wiki page where you can find slides from previous meetings, other resources that can be related to your work within the LISA Consortium. And so just a note about our current membership. So we currently have 3 co-chairs, myself, Alberto Sesana, and Jerry Wachter. So you'll see that Alberto has a little star by his name. He's an outgoing chair of the committee right now, but currently serving as 3 co-chairs. And then we have 7 other core members, so 10 total members of the committee. Sweta joined with Jeremy and myself a few years ago, and then we have 6 other new members, and we thank everyone very much for working on this committee and all the work that we need to do. You'll also see a note here about we have 2 observers, David Shoemaker and Martin Hewitson, who attend meetings and help us out as we need to communicate with consortium leadership and meeting organizers and things like that. So we also very much appreciate the observers who help us to do our work. I think I can pass off to Jeremy because we actually have a call for new members if you're interested in joining the committee.
Yes, thank you very much, Joey. So yes, if the scope of our activities sounded interesting, or if you looked at that last slide and thought, gosh, I would love to work with those people on some DEI initiatives, we are currently looking for applications for new members. We're hoping to fill 5 open positions this cycle. If you want to nominate yourself, that is definitely very welcome. Or if you think there's somebody else in the consortium who would do a great job in this sort of work, please definitely nominate such a deserving colleague. And in the nomination, all we're looking for is the name, rank, and institution of the person in question, a short narrative on sort of why you would like to join if you are self-nominating, or why you think the person in question would be a good candidate if you are nominating somebody else. And that's just sort of the bare bones of it, but any other information you want to include, perhaps your vision for just different initiatives you could start or ways to improve the DEI of the consortium, past activities you've been engaged in, suggestions, anything of that sort. It's sort of very open-ended type of an application, and you can email that to us. There's our email address right there. That goes to the entire committee, so all of these folks will receive that message, and someone will get back to you. The current deadline is August 1st, so next Monday, whatever time you want. And so to talk a little bit more about an upcoming major initiative that we have is we are going to be implementing a consortium demographics survey. So that, I think, ties in nicely to goal 1 of Kate's talk, right? And to talk about the goals of this particular survey, one thing we would like to do is establish a baseline for consortium demographics. And the idea being that the survey will be repeated periodically. And so eventually, you know, in the far future, by the time LISA flies, we'll have this nice longitudinal data so we can sort of see how does the composition of the consortium change over time. And this, both in the long term and in the shorter term, will hopefully let us answer questions such as the example given here. What are the demographics at different career stages within the consortium? And another important outcome that we hope for from this survey is to collect information about establishing accommodations at future LISA meetings. To give an example of that, many meetings are now thinking about how to accommodate people with caregiving responsibilities. Somebody might have to take care of a child or a relative. And so we're interested in seeing sort of, is this something that would be useful for the consortium? How would we go about implementing it? Other questions along this line. The survey itself, we are assembling ourselves, but we are not doing it entirely from nothing. We are sort of basing the survey questions, the compositions, and the best practices of how we design, administer, and analyze the survey based on other consortia and, I would say, professional sources within physics. And we hope to be sending this out within the coming months, we'll say tentatively by the end of the calendar year. And once the survey is complete, once all the data is collected and analyzed, we will be sharing the summary results with the entire consortium. So I would say that is something to look out for in 2023.
Should be wrapping up soon.
Yes, this is our final slide. And this is really just, if you want to learn more, these are places where you can go check it out. We have a public facing page, which that's just on the, sort of the, everyone can see at LISA site, and there's that internal LISA page, which was mentioned before. That's where we have a lot further resources, the foundational documents for the committee, and the archive of past presentations, other information there. And as mentioned before, but just repeated here, you can always contact us at that email address. So that's all that I have for you. So I will go ahead and take, I guess we can take any questions.
Okay, thank you very much, Joey and Jeremy. And Alberto, as departing chair, thank you for your work there. I can, by the way, tell you that it is a lot of fun to work with this group. It's something that I've really found as a pleasure for my participation in the LISA Consortium to sit in on those meetings and listen, learn, and offer some thoughts. So,
and we would
are there any questions?
Thank you as well, David.
Of course. Are there any questions for Joey and Jeremy on the activities of the DEI group? Let's see. There's a question from Alistair in the chat, which is, what kinds of questions and how will these be stored to meet GDPR? The dread control over information that Europe has put in place. Actually, it's a good set of rules. So your thoughts on that, please.
So I don't, let's see. So for the demographic survey, it's demographic questions that are all voluntary. Some about, you know, what working groups do you work in? Do you have a leadership role? So some things like that we want to know internally, and then general demographic questions that are optional, and following, as Jeremy said, best practices from other groups and consortium, so that we're sure that we follow all sorts of international regulations.
Yeah, maybe I could just be explicit. I meant here, will it be protected characteristic questions? Because that's where the real worry with how that information is stored comes. But at the same time, that might be the interesting information you actually want to get from the survey.
Right. I think it's true that there is some interesting information that we probably won't be able to collect based on regulations. But there's enough interest and impact from collecting information that we can collect that it's worth doing the survey.
And let's see, another question here. Do you have any specific priorities for the coming year?
I would say definitely the survey is one of our big priorities, getting that finished up, out, and then thinking about its analysis. Apart from that, we had mentioned we now have a LISA social media team liaison. And so we would like to maybe use that liaison to publicize some more like yearly events or days of recognition and such. I think those are two things we are definitely focused on at the moment. Joey wants to add anything.
Yeah, supporting the establishment of the Ombud's office, right, which is not necessarily within the committee, but I think that's something that we're also making sure goes forward.
Heard. Good. Any other questions? Alberto notes in the chat that the survey will be completely anonymous, which will help with the information control. All right, well, with that, let's actually close that and thank again Joey and Jeremy and the entire DEI team for carrying through with this. And I do invite you to consider seriously joining the team. It's a good group. It's a great group. So then let's move on to the final presentation before our break, which is to hear a LISA Odyssey, some personal reflections. And we're going to hear from two long-term participants in the LISA adventure. First off, Tuck Stebbins, and then Bernard Schutz a little bit later on. We're going to have to figure out how to divide these things up. So, Tuck, please go ahead.
Okay, I trust you see my slide.
Looks good.
Okay. So I have the trivial task of reviewing 50 years of the LISA concept in 10 slides and 15 minutes. I'm going to do that by essentially characterizing the LISA mission concept with these 5 unique features you see here. The constellation of 3 spacecraft, the 3 arms millions of kilometers long, continuous interferometric laser ranging, the use of drag-free masses, and time delay interferometry. Somewhat subjective choice, but I think it gets the essence. I'm going to break the time into 6 epochs, each of which will have an event that defines the end of that epoch, and I've picked a publication that kind of characterizes the state of the concept at the end of that period. So the shortest, perhaps least well-known, in some ways the most interesting epoch is 1974, started with a dinner conversation between 4 members of the Relativity and Gravitation subpanel of the Management Operations Working Group for Shuttle Astronomy. These 4 individuals were charged with coming up with ideas to carry out experiments in space for a number of purposes, one of which was detecting gravitational waves. And their report includes a 10-page summary of ideas that they spitballed at this dinner. Those ideas include ranging between almost free masses or to drag-free satellites. Drag-free satellites had already been demonstrated by the Triad mission a couple of years before, and all the players were aware of that. They suggested it would be a good idea to track multiple masses at right angles with nearly equal distances to reduce the effects of oscillator noise. They discussed the Michelson interferometer in a large orbiting frame. You see an example of that in the upper right graphic here. And they looked at some possible sources shown in this table in the lower right. And the principal science return would be just detecting gravitational waves. There's a document that captures all this, complete with calculations of noise estimates and signal strengths. The next decade largely took place at Jill at the University of Colorado, largely led by Pete Bender, with participation from a number of other staff members there, Jan Hall, Jim Fowler, Dieter Hills, Mark Vincent, and a visitor, Ron Webbing. They concocted a mission concept referred to as Lagos. It had one corner and two end spacecraft with a 90-degree included angle. 1 million kilometer long, nearly equal length arms, passively stable heliocentric orbits. So that's a very important discovery that Bender came to in about 1981, that by choosing the relationship between the inclination and eccentricity of the spacecraft orbits, they could obtain a stable constellation that appeared to orbit around the sun behind the Earth. They invoked heterodyne laser ranging. They assumed drag-free masses. They had not clearly articulated methodology for laser frequency noise reduction, basically using sum and differences of arm lengths. And there's some suggestion of time-shifted subtraction of beat signals, reminiscent of TDI, which wasn't to emerge for almost another 10 years. Further noise and source estimates, some advance, particularly with Ron Webbing's input on the sources, but the science was still largely focused on detecting gravitational waves with some astrophysics. There's this iconic publication, which I believe captures 4 of the 5 essential elements of LISA. So by 1984, in this LISA Symposium, most of the goods are in place. The next 6 years were largely spent with NASA-supported studies, particularly the Astrotech 21 studies in the workshop. This led to slight variations in the spacecraft architecture. And so here's a 4 spacecraft design with 2 corner spacecraft, 2 end spacecraft you see in the upper right graphic, 10 million kilometer long path lengths. There were relatively advanced designs for the trajectory, the orbits, the spacecraft, and the payload, with attendant mechanical and thermal analyses, drag-free assessment, the ever challenging propulsion questions, comms, power, launcher, all of the accoutrements of a full-fledged flight segment were advanced here. The sources were further enumerated, particularly in this final document you see referenced down here at the end, the Astrotech 21 workshop report. And the science case is broadening out into astronomy and fundamental physics. Interestingly, the first set of science requirements is shown here. It's 2 paragraphs long. In the next 7 years, the focus shifted to Europe, largely because NASA seemed disinclined to act on the recommendations of the Astrotech 21 survey. And so Pete Bender approached Jim Huff, Karsten Donsman, and Bernard Schutz about proposing for a European opportunity, the M3 mission slot. That resulted in the establishment of a pre-phase A study, followed by an industrial study. And then at the very end of this period, there was an additional Team X analysis. This is a concurrent design facility at JPL that does mission analysis that had an important impact on the European results just at the end of this period. The concept got renamed LISA for the first time. There was another concept initially called Sagittarius, later called Omega, advanced by Ron Hellings at JPL, that involved essentially geocentric orbits. The study team settled on the heliocentric version, and this version has all the features of LISA, as well as TDI coming in as a first generation way to deal with combining the signals from different arm lengths. The technology demonstrators started out initially as Elite, then called Smart 2, and eventually became LISA Pathfinder. The sources were the understanding of the sources were considerably enriched. The science return was considerably enriched. There are 3 documents of interest here. One is the famous Prephase A2 study. There's a system and technology study report that captures the industrial study. And then there's the TMX report, which captured the 3 spacecraft version as opposed to the 6 spacecraft version studied in Europe. And that concept was incorporated into the European results at the last moment. The next episode was the history of the first LISA project. This was a NASA-ESA combined mission, a phase A study. There were large project teams, both at NASA and at ESA. There was a LISA International Science team. There were corporate and agency center engineers and managers, and this was a vastly larger effort. However, the features of LISA largely remain unchanged, except TDI gets a little more sophisticated, and the engineering, design, and analysis got much. The technology demos continue and somewhat stall out, both for reasons on the US side and for other reasons on the European side. The understanding of the sources, again, continues to get better and better. The understanding of the science gets better and better. At this point in history, LISA is described by hundreds of documents. I've picked one here, so-called RFI number 2, for the Astro 2010 Decadal Review, as the closest thing to a single document that kind of surveys the state of the mission. We'll all know the next few years, the start is defined by basically NASA realizing that JWST is going to have a massive overrun that's going to be billions of dollars more than was anticipated. This happening in the fall of 2010. By the end of March in 2011, NASA decided to significantly restructure their science program. They pulled out of ExoMars, as many will infamously remember. They also terminated LISA, as all of us will infamously remember. And that pretty much terminated the NASA-ESA joint effort at the time. NASA went forward from that with this mission concept study, which is probably the most diverse architectural survey for for mission concepts similar to LISA, and it basically evaluated the science return, the cost, and the risk. And for 5 particular missions, did a detailed TMX studies of all of them. So out of that darkness and despair of sort of 2011, 2012 through to 2015, the LISA community was pulled out of that really by the success of advanced LIGO detecting gravitational waves in 2015, announced it in early 2016. LISA Pathfinder, launched in 2015, succeeded spectacularly in 2016. Both of those events affected a study affectionately referred to as the GOAT, that had been impaneled by ESA headquarters to look at architectural choices and descoping, and resulted in basically a re-endorsement of the LISA concept, albeit with an intermediate length arms. There was a series of European proposals with various names for mission concepts that either dropped out an arm or put it back in. Probably another parallel development was the GRACE follow-on mission, carried the laser ranging instrument that essentially demonstrated much of the LISA measurement technology, and was built by folks from the LISA community at JPL and Hanover, as well as various corporations. The sources enjoyed the addition of one new type, that would be the stellar origin black holes. But generally, I think the community's ability to analyze and project the properties of sources deepened further, and the science case got further enriched. I've included the references to the concept study at NASA, the GOATS report, and the final proposal that led to the current LISA project getting selected for L3 in 2017. So with that, I'll come to my final summary. The main features of the LISA concept emerged in 1984, and they've changed only slightly in the last 40 years. TDI was the one exception, and it really emerged in 1998 and sort of continues to evolve to this day. It went through at least a first generation, a second generation, a third generation. I think we've stopped counting now. The understanding of the sources and the expected science return from the project have grown immensely, particularly since the pre-phase A report, or with the pre-phase A report in 1998, but starting in 1993. What personal observations do I draw from this approximately 50-year history? LISA's revolutionary, but it will have taken 60 plus years to get to science return if it goes as we imagined for the next 10 years or 15 years, let's say. I would observe that flight projects don't naturally succeed. They can stumble for internal reasons. I think both LISA Pathfinder and ST7 did, or you can name any number of other missions launched by either ESA or NASA that have stumbled for internal reasons. Projects stumble for external reasons. Policies change, programs overrun. The first LISA project essentially was terminated because of overruns elsewhere in the NASA science program. Geopolitical events intervene, stuff happens. I would say we're now on the verge of an external threat of a sort we've never seen before. That's the LISA community. That's war in the Ukraine. You might think, well, how could that affect us? Well, the Russians have announced that they're leaving the International Space Station. That could be extremely disruptive for LISA. The Russians have withdrawn from the launch site at Kourou. They've withdrawn from joint missions with ESA. That's been extremely disruptive to the ESA science program. How these things will trickle through to affect LISA, if at all, remains to be seen. What do you do in these kinds of situations? Well, I think every day, everybody who's a supporter just needs to work towards mission success. We'll make as much progress as we can in the direction that seems like the right direction at any given moment. And I would note that LISA has advanced and endured through the strength of its community, the strength of its science, and the strength of its concept. Thank you.
Chuck, thank you for that whirlwind path through its history and then the necessary but unfortunate observations at the close. Bernard, please, it's all yours. And we'll take questions at the end.
Okay, very pleased to be here and very pleased to follow that talk from Tuck and endorse his conclusions. Tuck and I, of course, have been on this for a very long time. We saw many of the same things, and so these personal reflections are just that. They're somewhat different between the two of us. I'm going to emphasize particularly the science and some of my own experiences as we went along this line. But the very, very long timeline that there's been here is something that really is cause for reflection on how agencies make decisions and allocate money and assume risk and things like that. So I'll start because I'm most going to think about more the source side rather than the hardware side. When this whole thing began in the 1970s, what did astronomers know? About the sources that we now talk about so casually and with such confidence. Well, Martin Rees in 1978 produced this diagram that's shown here, which has been reproduced, has become legendary. It argues that that quasars should be powered by massive black holes with masses above 10 to the 8 solar masses, and that basically it's almost inevitably that you're going to get a population of massive black holes like that, and therefore inevitably that you're going to get quasars. You know, all roads eventually lead to the bottom. No matter where you start and no matter what path you take, you wind up with a massive black hole. This was convincing to a lot of people, but certainly not to the whole of the astronomy community, where the idea that black holes even, you know, might exist remains something people resisted. A number of astronomers. Those are the dramatic black holes, but also ordinary things like close binaries were just not getting very much attention. So the work that the group that Tuck mentioned, Hills, Bender, Fowler, Stebbins, and him here, Webbink and Hellings as well, did in the 1980s to put together the science case, to me, my perspective today looks really remarkable, because they understood that to be a galactic binary stochastic background at around millihertz. They understood that close white dwarf binaries could be potential individual sources. They postulated that massive black binaries would arise from galaxy formation, and you know, which would lead them to merger. And they also postulated what we now call EMRIs. And so the foundations of the LISA science case were, as Tuck has mentioned, were already present, even before we had the word LISA. And like I said, I find that really remarkable. The only thing we've added to this list in terms of a new class our Alberto Sesana is pointing out to us that we need to track these black hole binaries from that go through the LISA band and wind up in the ground-based band. So from in the 1980s, there was this proposal of Lagos, as you've heard. Could the idea be taken seriously? It was a consistent proposal: 3 spacecraft, heliocentric orbit, inclined orbit, keep things. Sorry, I had a drop out just then, but without station keeping, a lot of fuel. But against it were the fact that the existing gravitational wave detection that hadn't demonstrated any emissions, and also that there was just not much interest in the astronomy. NASA encouraged the study, didn't fund it, as we've heard, and a lot of people in the gravitational wave community, including myself, were very focused on the ground-based, getting the ground-based detectors approved, and weren't taking a hard look at this at all. That changed in 1982 at this meeting in Argentina, when this group of people, and here's a partial list: Karsten Donsman kindly gave me his recollection of the names of some of the people who participated in these things. We were stuck in Argentina because there was a disruption in travel after the end of the meeting, so we had the opportunity to do some brainstorming. So and out of that came this proposal with that, sorry, that diagram there, that picture of 4 spacecraft. This central spacecraft was split into 2. And we proposed it for M3. ESA allowed it to be studied. This is the proposal's author page. ESA allowed it to be studied to phase A, which it knew it wasn't going to get approved because it was going to be too expensive, but it wanted to see what would come out of a phase A study. Was it really something you could believe? Interestingly, the competition for M3 was won by the Planck mission. And we were suggested to submit for a cornerstone. I just pulled the sensitivity out of that M3 proposal because it's still on my computer. And it looks a lot like sensitivity curves that we've been showing ever since. And you know, you've got the stochastic background, you've got the dwarf background, you've got EMRIs there in that sort of gray semicircle down toward the bottom. You've got individual coalescences. So again, these things are things we've been talking about, but what changed over time was the confidence that we had in them, partly because of astronomical discoveries, partly because we studied them a bit better. So after that, from the period in 1995 on, is a time when LISA became more mature. So the cornerstone proposal had this diagram, which is a 6 spacecraft. Again, at the vertices there were 2 spacecraft, not joined into one. It was adopted by ESA as part of Horizon 2000 Plus. Here's the center we showed, and pretty much the same. I'm not going to go through it. We were at the time we were distinguishing a 5 sigma detection curve from a 1 sigma noise curve. Those are the 2 curves that are sort of parallel to each other. In 1985, we produced the pre-phase A report version 1 with those 6 spacecraft. Then there was the TMAC study of NASA, which pointed out that it was much more sensible to go for 3 spacecraft, and it would be possible to do the control to keep the 2 test masses within each one, understanding the measurement direction. And so that, in the end, produced what we call the book, the pre-phase A report 2, 1998. Notice that this is pre-phase A. We weren't in phase A. We weren't offered phase A. We were, but we were encouraged to keep studying it. So there were 3 spacecraft and 5 million kilometer arms. And that's something that anybody who was around at the time has a vivid memory of that yellow document with that cover. Inside that yellow document, just to illustrate, the science case was much more developed. We had separate diagrams for all the different kinds of sources, but that illustrates how much more space we gave to it and how much more we could say about it. Much more. So toward the end of that period, it became clear that NASA was very interested, and it would be crazy for the 2 agencies to compete on this. And so they basically agreed to have some sort of 50-50 cooperation. And in 2001, formed the LISA International Science Team List, chaired by Carson Dunsman and Tom Prince. And Kip Thorne was a notable member. Many other people, the usual suspects, were also on it. Early meetings showed that scientists from the 2 sides of the Atlantic found lots of areas of agreement, but the agencies had difficulty. And up until that point, they had worked together where one agency was the lead and the other would be have a minority stake, like the Hubble paid, I think, 20%, contributed about 20% to Hubble. So basically there was a lead agency and the other one had to follow whatever lead agency wanted to do. But here it would be 50-50, but the ways they costed them missions and ways they funded missions, very different on the two sides of the Atlantic. And so with the best will in the world, the reps of the agencies did have trouble figuring out how to divide up the work and how to agree responsibilities. Within American NASA gave responsibility for LISA Goddard Space Flight Center, despite the fact that JPL up until that time had been a stronger participant. The Goddard team were very experienced with astrophysics missions. I found them in my first meetings going over there, frankly, a bit cynical or patronizing about academic scientists. You have to again realize in most science missions there was a payload and there was the spacecraft, and the agency would arrange for the spacecraft, and the scientists, the academics, were heavily involved in the payload. And so Goddard had a hard time understanding or getting their heads around the fact that there wasn't really a separable science payload in LISA, because things like the microthrusters and so on would be part of the spacecraft, but were absolutely central to the measurement system and so on of the payload. So there were all these cultural tensions that I remember vividly from that period of time. Sterl Finney at Caltech and I chaired the data analysis working group. One of the things we initiated was the mock LISA data challenge around 2005. Again, the two US and European contributors to this group worked very well together, and it was really a pleasure to these meetings. The tensions, people wanted this thing to succeed. The people did resolve their tensions and lived with them and so on. And basically my memory of the decade of cooperation from about 2000 to 2010 is that there was steady progress in the design, and the technology kept getting better, the science, there were lots of reviews, there were ups and downs, and we thought maybe some money, no, not so money. Lots of waiting for things, but still plenty of optimism. So then 2011 was a keystone year.
Bernard, you should look at around 5 minutes or so.
Oh, that's fine. This is, I have no trouble doing that. In January of 2011, there was an open meeting in Paris, which ESA organized, because there were 3 cornerstone missions that were coming up for launch, and they didn't know which order to launch them. There was JUICE, which is a Jupiter mission, Athena, the X-ray mission, and LISA. And each of them made a presentation to a big audience that included the selection committee that was going to decide which of these would go first for a launch estimated to be 2021, if I remember correctly. But there were lots of members of the general community in the audience. I had the privilege of actually presenting the LISA mission at that meeting. And remarkably, all 3 of those were expected to be joint 50-50, roughly speaking, with NASA. There was an extraordinary degree of anticipated cooperation going on. LISA was the audience favorite, I can say. There was a straw vote. There were also, applause after the LISA talk, no applause after the other 2 talks. But that's not how things are judged, and properly how things are judged. JUICE won the selectors were still worried about the LISA technology being something that was undemonstrated, and you couldn't demonstrate it on the ground. And they wanted to see LISA Pathfinder fly, which it had not yet done. Also, LIGO hadn't made a detection, so there were some people saying, oh, well, are there really gravitational waves out there? There weren't many people saying that, but that was one of the themes. But the astronomers in the audience, the attitude there was very clear, and I think that's why in the end, we did survive this 60-year period that Tuck was talking about, which is there was a general recognition by this time in the astronomy community that this thing should really be done. And one way or another, it's got to be done. But so that was So although we didn't get selection, we were very encouraged by the response, but then 2 months later, NASA withdrew from all three because of the cost overruns on JWST. Now we've seen JWST get launched. They spent their money, the cost overrun money, very well. It's working very well, but it did have a devastating effect on these three communities, particularly hit ours. The Europeans were very disappointed, of course, to lose their partner, but the Americans had it worse because they didn't have a project at all. And many people who were part of that team then just haven't rejoined. So this is my last slide. We got back onto the road the next year to ask the team to descope. We called it ELISA. Again, it had only 2 arms instead of 3. We had our LISA Symposium in Paris in 2012, but that was not a very happy affair. But ELISA was reproposed to ESA in 2013 as the new Gravitational Observatory, NGO, which was an acronym chosen by ESA, not by the team. And this one was presented by Karsten and Stefano. And was accepted by ESA tentatively for the third, which was then had been rescheduled for maybe 2034. But ESA wanted, it's a fundamental design that we had, from the 1980s, was appropriate for something going in 2034. That's why they established the GOAT, which Tuck was telling you about. That was chaired by Mike Perriman, and among the members were some of the insiders like Stefano, Guido, and myself. It validated that design. It looked at other very interesting things to talk about, but it validated that design. And then what happened was 2006. That was around the GOAT was still meeting in 2016 when we had spectacularly successful early performance of LISA Pathfinder out of the box, no problems. It was clearly one of the best missions ESA have ever launched. It was successful in attaining its goals. And then, of course, that was coming at the same time as LIGA was announcing its first detention. And change within the ESA hierarchy was amazing. From keeping us at somewhat arm's length and saying, yeah, but prove it, oh yeah, well, they suddenly became big fans. And we did that out of scope meetings, knowing that we had a mission. And so that's what LISA Pathfinder, that's the artist's idea of LISA Pathfinder. This is I'll finish with this picture, which has Stefano and Karsten with Michael Perriman in the middle. This was the control room for LISA Pathfinder in Darmstadt. These are the guys that, these two guys, particularly Karsten and Stefano, we owe this project to the way they've shepherded LISA along, but also the way they made LISA Pathfinder work. And I think that's an appropriate way to finish.
All right, I thank you, Bernard. I think thanks to both you and to Tuck for giving us this window into the long history of LISA. So, are there any questions? I don't actually see any in the window at this moment. Well, let's see, can you give a who is who on the last photo? Are there any other names that you could call out there?
Oh, sorry, I've
one moment too quickly.
Yeah. The problem is that on my screen, I don't, so all the pictures of everything's going on. Oh, okay. Well, that's Karsten, Stefano, that's Mike Perryman, who was chairing the GOAT. So this was a visit of the GOAT to the Darmstadt control center. And I don't know.
I think that's David Robertson in the back there.
That's David
And,
yeah,
and
that's
just
right.
the edge of my face on
Here?
the right-hand margin.
This is you, is it? Okay, that's
Yeah.
good. That was just the edge. Yeah. Lots of the other team members were there, and I didn't want to minimize the contributions that everybody else is. But I like the way this captures. Yeah, that's right.
It's good.
That's absolutely right.
So one more question for me, where we should probably have a break soon, but we see how long it takes to make something like this come together.
Yeah,
we're clearly really late in making our follow-up mission happen. What should we do next? It'd be fun to get a short idea, both from Bernard and from talk about what the next mission should be. Bernard, you first.
Lisa Pathfinder. I think we have to realize that there are other players. The Chinese really want to launch. The Japanese have this challenging but interesting proposal for for a mission in the 1 Hertz band between LISA and ground based. I would guess that my fingers would be crossed for the Japanese mission to catch and maybe attract cooperation with agencies like NASA and ESA. And if the Chinese can pull off what they would like to have a LISA-like mission going at the same time as LISA, which would be fantastic for the science. So yeah, that's what I'm thinking.
Okay, good. Thank you. Tuck, anything you'd add on your twist?
I would, as I think many will know, there are multiple candidates for a LISA follow-on. And I would say what's most important to do next is to essentially drive forward the analysis of those concepts, the science they can produce, and coalesce the community behind the one which is the most viable, the most promising, given some reasonable assessment of cost. So I think we need to, so I wouldn't recommend one mission over another, because I don't think we know enough about any of them. So I would have said the community's job here is to further analyze all of them, both the concepts and the science they can return, and then make a selection as to which one they want to represent to, Voyage 2050 or a future U.S. decadal.
Spoken like a former employee of NASA, but I can't argue with it. I'm reminded in the chat that we do in fact have a session tomorrow. Stefano Vitali will lead it for a discussion of Beyond LISA in connection with the ESA initiative to invite a Voyage 2050 concept. So for all of you who are intrigued by this question of what we're going to do next, the younger ones among you perhaps, please tune in for that session. I'd like now to draw this first, I guess, 2/3 of this session to a close so that we can have a short break. We are scheduled to get back together at 15:50 in my time. It's another, 12 minutes from now or something like that. And I think we should try and stick with that so that we can wind up in a timely sort of way. Are there any other comments from the organizers, or should we just close down now for a few minutes?
I think we can power down for a few moments. Maybe just one clarification. I believe it's John Conklin that is chairing the panel, just in case Stefano is worried that he's missed something.
Yeah, and if I can add that there's also a parallel session in the morning on Beyond LISA, morning European time, followed in the afternoon by the panel discussion. So a multitude of goodies about the future to be discussed.
Okay, good. Thank you all for these clarifications, corrections too. So talk to you all in a little bit over 10 minutes. Thank you again for the speakers so far, and we look forward to hearing Jonah after our short break. We'll pick things back up in about another minute.
I think we can get started, David.
Good. I'd like to welcome you back to the close of this session. We have one more talk. Jonah, who's at Caltech and has worked extensively in the domain of LIGO Virgo data and understanding how to share it with a larger community, going to talk to us about the last mile for gravitational wave data. Jonah, it's all yours.
Okay, that's great. David, thank you so much. All right, well, thank you for the introduction. My name is Jonah Canner. I work at LIGO Laboratory at Caltech. And so I was asked to come and speak today about how we manage our data, in particular our public data releases for LIGO in this case. And so I'm going to frame this up as a last mile problem and tell you all about it. So by analogy, the last mile problem in transportation is a pretty classic, well-known problem. The concept is that you've got a person who's maybe at her home, and she wants to be able to access some network of transportation. Maybe that's a highway system, maybe it's a train system, maybe it's a metro or public transit system. And the issue is that between this person, in this case the traveler, and the transit system, is we've got this last mile where, say, that it's difficult to connect, right? She might live a mile from the closest bus stop or a mile from the closest train station. And so the question is, how do you connect this person with the dense network that's going to allow her to get to where she wants to be? In transportation, the solution is actually really simple. It's a bike. And the solution in transportation is we need to be building more protected bike lanes, so it's easier for people to travel that last mile and get to those train stations. And so I want to make, thank you for the support there. I want to make a connection here with data and what this last mile problem looks like in the realm of public data. So here, our traveler might be someone who wants to get involved in scientific research in some way. Could be a student, high school, graduate, undergrad. It could be an expert in another field, right? One thing that when we talk about users of our data, we need to remember that people who have expertise in one area might not have expertise in our area. So where we see this a lot in LIGO, we see astronomers who might be interested in working with LIGO data. We see people who are theorists or numerical relativists who maybe know a lot about our sources and black holes and gravitational waves, but have never actually worked with LIGO data before. We might have amateurs. So amateur scientists are really an interesting community, a lot of enthusiasm. And then you can even have people with other interests with use cases you've never thought of. So you might have artists who want to make use of data to create some sort of installation art. You might have musicians who want to use it to make some sort of musical piece. And all these people are potentially users of our data, but they might encounter different challenges, right? And those challenges are what I'm calling this last mile, this gap. And on the other side of that, the analogy of the transportation networks here are we actually, as expert users of our data, we actually have dense networks of expertise that we rely on. And this is all sorts of things, some of which we are aware of and think about, but some of which we forget. And it's easy to forget the things we have access to, where for other people who don't have access to those things, these can be real barriers, right? So we, of course, have access to the data, but we also have access to software to work with that data. But then just as important as the software, we have access to colleagues and peers who can show us how that software works, tell us how to find that software. We have access to journal articles, and not only access to the journal articles, but knowing which articles to read, which ones are relevant, the background and experience, both to find those articles and to read and understand them. And so for these types of potential data users over here, they might see a real last mile problem, a real gap in access, a gap in knowledge, and gaps in resources in being able to access our data and our software and make good use of it. At this point, I realize my voice is pretty scratchy today. I am recovering from COVID-19, so I apologize that my voice sounds a little unusual or sounds different than it usually sounds for me. All right, so why this matters? So I actually thought the first speaker in this session did an incredible job talking about the importance of access in the scientific field, and I want to kind of echo some of those themes. This last mile problem has serious implications for diversity, equity, and inclusion. If the only people who can figure out how to work with our data are people who are already enrolled in a graduate program and already have access to all the same tools and resources that you do, then we have a problem, right? If we want to recruit people of different colors from different socioeconomic classes, and actually the one that surprised me, but I'm now appreciating is incredibly important, from a diversity of countries and nations, then we really need to solve this last mile problem and make sure that people are able to access our data and software. This last mile problem has huge implications in terms of efficiency and productivity. We are in an academic field. Because we are in an academic field, we have very high turnover rates. And what I mean by that is students graduate and then new students come in. Postdocs move on them from their positions and new postdocs come in. So by the nature of our academic field, we are constantly retraining people. Even the experts are constantly being trained anew as we have new students and postdocs and junior scientists coming into the field. And so the time and energy that it takes to train those new graduate students and new undergraduate students and new postdocs, that creates a large overhead in our ability to move our science forward, right? So the easier we can make it to learn to work with our data and software, the more quickly those new students and postdocs can get going on their work, and ultimately the more work that they can get done and that we can get done as a field. So it's really important to remember that when I talk about increasing access for public data, I'm not just talking about increasing access for people outside our field or outside our community in some way, but I'm talking about increasing data and access for everyone, including people inside our field. And that's really important, is that I don't see this work as work for some public that's outside and far away. I see this as work for us. And that's a message that I'm struggling to share with people. And then the third area is climate. So in this case, so for the bite, it's an issue of climate change and our the atmosphere around us. Here in the metaphor for data, the climate means our work climate. What's the environment like in our workplace? Is our research environment friendly and welcoming to new people, or is it scary and off-putting to new people? So again, this goes back to diversity, equity, and inclusion. All right, so that's the way I'd like to frame it up. Let me talk about some specifics of LIGO data and where I see gaps and the types of solutions that we are trying out. And actually, this slide is maybe a little bit general. So I think this could apply, certainly applies to LIGO. It's based on my experience, but I suspect also can apply to LISA and probably also applies to many communities as well. So what's the issue? Sure, our data are public. I can take all our data and put it on a web server and anyone can download it. That's easy. But are the data easy to find and download? Do I recognize the file format? Can I figure out how to open it? So that sounds a little bit trivial, but you have to remember that within our expert fields, we use lots of file formats and we're familiar with them, but people outside our field might not be familiar with them. I can tell you, I had the experience of going to graduate school for physics, and then at some point encountering astronomy data sets for the first time. And I didn't know what a FITS file was, and I didn't know how to open a FITS file. And I get emails from folks all the time asking me what's a GWF file, or maybe what's an HDF5 file, and how do I open it in Excel, right? And so, as a bit of a tongue-in-cheek example, our student here has gone to somebody's public data server and downloaded a file called data.wtf.gz. And maybe the student doesn't know what .gz is, and maybe she doesn't know what a WTF file is, and maybe she doesn't know how to open it. All right, so moving on. Can I load the data in a spreadsheet or text file? Are there secret steps to processing the data, right? This could be like filtering or signal processing that the user might not know about. Can I find the software? And even if I can find it, can I get it installed on my computer, right? A big one here is, can I install the software on a Windows machine? Which in a lot of cases you can't. Once the software is installed, can I figure out how to use it? Of course, it's a huge issue. And do I know how to ask for help when I get stuck? So these are, I think, very general questions. And then applying them specifically to LIGO. So these were the sorts of issues we encountered, say around 2014. All the data were stored in a special file format, GWF. So this is a file format that's not used outside the gravitational wave community. It doesn't work with outside tools. And also, critically, you can't open a gravitational wave frame file on a Windows machine, to the best of my knowledge. All data access requires programming. And, I have interactions with high school teachers who've never programmed before. So for them, this is a huge barrier. We have specialized libraries that at the time lacked examples and documentation. So the only way to learn to work with some library was to go down the hall and ask a person who you have personal access to to show you how it works. And of course, when you're talking about public data, people might not have access to those experts. So we need examples and documentation. Signal processing is not something that everyone knows. It's certainly not something I was trained in. And so as graduate students, we kind of put ourselves through a crash course on it. But this is an extra layer of things that people need support on. And with LIGO data, and I expect also for LISA data, the data contain detector artifacts. And so folks working with the data need to be trained on what those artifacts are, how to recognize them, and how to deal with them. All right, so here are some solutions for LIGO data. So in a sense, this is the bike, right? This is how we're going to get people across that gap for the last mile. So we've started making our data available in multiple file formats. So in addition to GWF files, which are gravitational wave frame files, which are not used outside the gravitational wave community, we also make our data available in HDF5 files, which are still new for a lot of people, but at least are supported by a broader community outside of science, right? So HDF5 files are used by some fraction of the data science community. And so there are widely available tools to support those files. And then in addition, we also make our data available through a streaming service. So in a sense, people don't have to deal with a file format at all. And I'll show you later, we've also made available an app which will convert the data into CSV or text files. And certain user communities, again, amateur scientists, high school students, they want to be able to open up data in a spreadsheet. And so we are working hard to give them the ability to do that. We've created and worked with colleagues throughout the gravitational wave community to create software examples to show people exactly how to get started. And we've made a conscious decision to focus on the most basic tasks. So how do I load the data? How do I open up a file and load it into whatever software environment I'm working on? How do I pre-process the data? For us, that can mean a lot of signal processing, like whitening or filtering or these sorts of things. And how do I plot the data? I like to focus on these because I think folks feel like when they can plot the data, then they can see it and understand it in some way. And so I like to emphasize all the steps that get me to a point where I can make a plot that's hopefully interesting and useful. One area of solutions we've been looking at are online tools. And I really like these because if you provide an online tool, then now no software installation is needed. And we're using different types of online tools. One type of online tool we're using are these online Jupyter notebooks. And this is something that I've seen used in other fields as well. And I think has become a popular way to let people work with software without having to do installation. So this can be things like Google Colab or MyBinder are the two that we're really using right now. And so we're able to provide links on our website where somebody clicks a link and boom, the notebook opens in their web browser. And so by running the notebook on a remote server in their web browser, they don't have to install anything locally on their computer, so they can get started right away. Another environment that we've been using is a Python package called Streamlit that makes it relatively easy to develop Python web-based apps using Python. And because we are primarily a Python shop, this felt like a good fit for me. Links to resources, of course, there's lots of software libraries, related data papers, tools, web services, workshops and online courses. And I'll talk more about the workshops that we've been running. I see these as a really important piece of how we're helping train people. So in addition to providing resources on a web page, we actually provide direct trainings to people. And I think that's really important. We support a help desk and a discussion forum. And then finally, we've put all this together on an integrated platform that we call, with the unfortunate acronym of GWASC, that's the Gravitational Wave Open Science Center. You can find everything that I'm describing at gwasc.org. So I encourage you, if you haven't already, I encourage you to take a look at the Gravitational Wave Open Science Center. All right, so that's an overview to show you in a little bit more detail what some of these features look like. We are supporting a discussion forum at ask.igwin.org. I'll try to provide some notes on that later. We also have a help desk where people can send emails. We have online courses, web apps, tutorials, and workshops. There's the URLs for all of those. I'll highlight a couple things here. As we're doing right now, this age of COVID has moved a lot of things online. That has pros and cons, of course. But one of the things that's a pro of moving to online meetings is that it makes meetings much more accessible. So all of a sudden, people don't necessarily have to travel for a meeting, and travel can be a major barrier to people's participation, especially if they're in a country that doesn't, that they're in a country that doesn't have access to a lot of resources. So we've moved our data workshops online. I'll say more about this later, but in general, I'll just highlight that this has really broadened dramatically the number of people participating. So originally we were doing workshops in person. We get 50 people in like a lecture hall at, say, Caltech or at a university in Paris. And that was great. We had a lot of fun. We learned about LIGO data analysis. But now moving on to online, we've gone from like 50 or 60 people to like 1,000 people participating in a workshop. And our most recent workshop used a hybrid model where we were online for some content, and we were also working in person but not in person at a single location, but at these multiple hubs around the world, so people could choose their location. We had 15 study hubs for our last data workshop. And so we were able to include hundreds of people in person and thousands of people in total. And then also I'll show more about this later, but we've been developing these web-based apps that are useful for LIGO data analysis so that you can actually create some plots and download some data through a web app using the Streamlit platform in this case. So here are a few notes about using Jupyter notebooks to show people how to work with LIGO software. So what I like is that these notebooks can be run online in the browser, and the user then does not have to install any software. And because they're making use of Python programming, they're able to learn to work with the specialized analysis libraries that are developed for collaboration work. So work that goes into LIGO Virgo Cagra collaboration papers. Most of the software is open source. So there's a large number of these libraries, but I'll highlight GWPy, PyCBC, and Bilby just to name a few. And what we try to do at GWASC is we try to maintain these tutorials that show people how to work with these libraries and to work with the data. And I have to say, this works largely because we get really great support from the collaboration. So in many cases, we're able to recruit expert analysts who may well be junior scientists, so who are often postdocs or graduate students who are working with these libraries. And these experts create these Jupyter notebooks. They're in publicly available GitHub repos, and then we set up the links and everything so that it's relatively easy for people to run them in their browser. And then one step even further in terms of trying to make our data easy to work with, we can not just eliminate the software installation, but also eliminate the need to program. So again, if you're a high school student trying to do a science fair project, if you're an undergraduate professor trying to run a course, programming might not be something you have experience with. And so it can be a huge burden for people. And so here we actually try to take the programming out of it altogether and give people these web apps to interact with the data. Right? Oh yeah, this is a little video showing you how the app works. You can pick an event. So these are all detected gravitational wave events. Whichever event you pick, in real time, the program downloads the data from our server. It then does some light signal processing and produces some plots. There are controls on the left panel so that you can make adjustments on the plot, so all the plots are interactive. And then you actually have the option to download that data as a CSV file, which again, if you're a person who's working on a Windows machine and doesn't want to do any programming, getting that data into a CSV file could be really important, because now you can open it in a spreadsheet, or you can open it in a text document, or you can open it in whatever tool might be comfortable or familiar for you. You don't have to use specialized tools if that's not the direction you're going in with your work. Okay, so I guess I had a second movie, great. So I wanted to talk a little bit more about our open data workshops. So these are annual events. We recruit, I'd say experts, but they're very often junior scientists to prepare material, lecture, and mentor. This does create visibility and experience for the mentors. You can see a few photos of the mentors from our last open data workshop on the right. And on the Open Data Workshop webpage, we prepared these introduction videos to each mentor. So you can click the video and see the mentors introduce themselves, tell you who they are. The data workshops include hands-on software examples. So that's primarily those Jupyter notebooks that we were just looking at, and also data challenge problems. So we provide the workshop participants, well, I don't have to tell the folks who work on LISA about data challenges. You guys are masters of data challenges. So we've prepared a very small LIGO data challenge where we put some simulated signals into LIGO data and then ask or invite workshop participants to try and find those signals. And this year we had this hybrid format with 15 locations. which I would argue is a scalable format because you could always add more locations if you're so inclined. And it was paired both a live event with an online course. And the beauty of that online course that's on the Thinkific platform, that online course is now available forever. So folks who want to come in a day, a month, or a year after the event and work through the material, they have the option to do that. So that online course is available for free, right now, forever. Here are some pictures from the Open Data Workshop. Again, it was spread over 15 locations, just to give some sense of the scale. You can see pictures from various locations. Here's a few more from New York at the Flatiron, from Paris at the APC. Here's one up at Northwestern. You can see the map with the 15 locations marked. A lot of the participation comes from India, over half. So that's, talking about this diversity of geography. When we did workshops in person, almost no one came from India because it's really expensive to fly and you have to get a visa and it's not easy. But when you go online, it turns out there's a lot of interest in the gravitational wave science in India. And so all of a sudden, all this material and information that was not available to these folks, all of a sudden now it is. And it's not just India, we get participation that's really global. So various countries in the Middle East and Asia, in South America. We had not one, but two study hubs in Mexico. So a lot of places that might not be the first places you think of as hotbeds of gravitational wave research activity, we have participation. Here's a study hub in Korea.
Sort of 5 minutes, Jonah.
Okay, good, thank you. All right. All right, so I'll move on. So on the topic of getting help, we have set up a discussion forum at ask.igwan.org. So this is a place where anyone can go and post a question and get answers. So I think that's a relatively new resource. We did use it for the Open Data Workshop, and I think it's been useful. I did want to spend a minute on impacts. My favorite metric of the impacts of open data are scientific publications, and we are seeing over 100 publications per year at this point. So that's a pretty significant contribution to the literature. And then of course, these open data workshops were impacting hundreds, if not thousands of participants at this point. So we do think that, that this work is impacting a lot of people. All right, so the second half of this talk is on managing complex data. I will try to keep us on time. But in terms of managing a complex data set, it's important to remember you have a diversity of data users. So you have some range of users from experts to non-experts, and they want different things. Experts typically want access to a lot of data. They're going to be asking for all your control signals and readouts and environment monitoring. Where non-experts, what they're going to want is lots of support. So they're going to be using the most basic data product, the one that has all the signals in it. But then they're going to want lots of help in learning how that works and how to work with it. For LIGO, I like to think about this kind of mountain of data. And at the bottom, we have our raw frames, which in the case of LIGO is 250,000 channels per year. Most of these are instrumental monitoring channels that describe the state or the health of the instrument, or say the environment at any given moment. But of course, most of the science is contained in the strain data, which is really just a few channels. And so going from the raw frames, which contain everything, to the strain, we go from petabytes per year and say hundreds of thousands of channels to really essentially one channel that's the strain channel, and is more like a few terabytes per year. So less than 1% of the data contains 99% of the science. And so a lot of our effort goes towards supporting and making available the strain channel. And then what I've learned more recently is very important is supporting data releases that go along with our scientific results. So I just show the results as a garden with many flowers blooming because our community is large. And so there are many analysts writing many papers and doing lots of work. And what we've learned to do is to store our analysis results in Zenodo. And Zenodo is a great tool that allows analysts to manage their own data analysis products, basically so that I don't have to, right? Instead of me as one person, or say our small GWASC team, which is a staff of say 3 or 4 people, managing the results of dozens or even hundreds of papers, we invite the authors of those individual papers to curate their data analysis data products in Zenodo, and that makes those available to the community. And then our GWASC staff really focuses on the strain data and making that available and accessible to the community. For any public release, it's very important to follow FAIR principles. That's findable, accessible, interoperable, and reusable. This is a general set of principles that covers all sorts of public data release. And of course, we do follow them for LIGO. And, you know, and I'll highlight here that, you know, because our strain data are important, we try to make them accessible in many ways. So we provide access to the strain data through web downloads. So that's probably the simplest to use. It's a point and click interface. We have the CERN VM file system, CVMFS, which is really great for computer clusters. And then we also provide this thing called a network data server, NDS2. And this allows people to get small snippets of data, which sometimes is really convenient. So we try to make it, you know, you can have one data set and you have to agree what your data are. And then once you know what your data are, then you can find lots of ways to make those same data available for folks to make it as easy to interact with as possible. Here's just an example of our point and click interface. You go to our website, you click download data, you scroll down and find the data set you want. You can query by time. So you just put in the time that you want to look for, and then boom, you get back a list of all the data files. And it's as easy as picking the one you want, point, click, and it downloads to your computer. So for a lot of people, that's just the easiest way to get data. But then we provide, you know, other paths as well. All right, so I think I should stop there. So as a summary, we're trying to solve the last mile problem for public data. I think it's a very high stakes problem. It's important for diversity, equity, inclusion, and it also improves the efficiency and productivity of our field. And when trying to think about how to manage data, it's really important to consider the needs of both experts and non-experts. And experts are going to want lots of data and lots of services, lots of web services. And non-experts are going to want a lot of support. And it's important to keep all those many users in mind when designing a data release. And most of the tools that I've described are available at gwasc.org. And I'd encourage you to take a look. And that's what I wanted to say today. Thank you all so much for the time.
Jonah, thank you. It was really nice the way your talk tied into Kate's and the ability to give access to people from a broad spectrum of perspectives. Really neat, and also a lot of good lessons in there for LISA. We certainly want to make sure that the broad community can access these data for a variety of different purposes, and these are lessons that we can learn from. Let's turn to the questions. There's one from Valdemar Martins. Writing good documentation, tutorials, and web pages takes a lot of time. How do you find and motivate people to do that work? And allow me to, something I was thinking about asking as a question, which I think ties into this well. How many people are involved? I know it's a relatively small team that's really dedicated, and then little bits and pieces of other people along the way. If you can give some notion of how many people it takes, that would be really useful. So please.
Yeah, no, I'm happy to respond to that. So yes, this is a challenge. So those open data workshops have been instrumental for this, right? And so here's what we've done is, you know, originally we were trying to write documentation ourselves. And from my perspective, that we reached limitations. So our paid staff is maybe of order 3 or 4 people, depending how you count. Instead, what we've done, we set up these open data workshops. For the workshops, we invite in a team to run that workshop, a team of mentors. And that's of order 15 people each year, right? And we have some people who show up multiple years. And of course, we have some new people every year, right? And so every year we get a team of 15 people together and we say, look, here's the set of tutorials and documentation we have right now. Please update this. And so we get that team together about 3 months before the workshop. And for 3 months in advance of the workshop, 15 volunteers update our tutorials, update our online course, update our documentation. And then that's what keeps it fresh, right? If we didn't have that update every year, then I think, the hard thing about documentation, it goes out of date very fast. But by forcing us to update every year, having a specific event, and then recruiting volunteers to help with that, I think we've been successful in trying to do that. And one of the things that this is a biased perspective, but I believe that because WASC started doing this and started making these tutorials available and started making this kind of documentation available in Jupyter notebooks with examples that focus on the basics, I believe that I've seen a culture shift where more and more of our developers, when folks write software packages, we've seen a culture shift where they expect to do this themselves. And so in some sense, I believe I'm seeing copycats in a good sense, where where I've seen people do a better job with their own documentation. I believe because we've set the example.
Thank you. I can just quote a compliment and a thank you from Jennifer Lee, who found the data workshops this week to be really enlightening, educational, and approachable. Kudos for making the data and processing available to all. She's a hardware technologist and probably won't be a data consumer, but likes the opportunity to try. There's another question, which is what the relative sizes of the data packages from LISA and LIGO, Virgo are. And it's got to be different by a factor of 10 to the 4 or something like that because of the sample rate and also the frequency range. The data problem, the data processing problem is very, very different because for LIGO and Virgo, and even for Cosmic Explorer or Einstein Telescope, we don't have a pileup. We don't have simultaneous signals that need to be ferreted out. Whereas LISA is all about that. So it's going to be a different kind of challenge. You'll be able to fit it on your wristwatch by the time the data come out. But then actually to do something interesting with the data will be really pretty challenging, I think. Are there any other questions for Jonah? Let's see, here's a question from Alistair Taylor. I wonder if it's worth building on existing amateur astronomers who might be keen to work with this and manage it. Do you find many of the people that you're working with, Jonah, are astronomers and are interested in this from the perspective of those amateur astronomers with polishing their own lenses and so forth?
Yeah, that's a good question. We certainly get interest from people who there's a big class of people I would call amateur scientists, right? So people who are interested in LIGO and may or may not have a background in science, or may have a profession outside of science. And I think I would just say that I'm not sure what to say about it. I mean, what is the question? Can we somehow leverage them to make our software better? Is that the question?
Maybe I'll expand and articulate. So, for example, the 03 and 04 have large community projects where amateur astronomers will do follow-up observations, and they're heavily involved in, these kind of projects, and they're keen. Like a lot of them are very keen, and it's kind of just, it happens that they're not scientists full time. They have other jobs. They went into other careers, but they've got all the skills required, and a lot of the other projects I'm thinking of are like run by the American Association of Variable Star Observers. There's a huge community there that do a lot of very good science. So, if these communities exist, maybe we can go to them and see what they think and take their advice on board.
Yeah, I mean, I think that'd be great. One of the things that we're trying to do is encourage more of our community to participate on our public discussion forum. And what that does is it, in a sense, levels the playing field, right? So we have a discussion forum where where people can come in regardless of their university affiliations. And I think that invites amateur community, invites, experts who we might not know, right? It invites these amateurs to come in and share their knowledge and expertise and answer questions and be resources for the community. So I would love to see more of that type of engagement.
And I think we have one more question from Martin Hendry. Following on from David's comment about the global fit aspect of LISA data, this might require LISA to introduce some more sophisticated data analysis methodology from Jonah's experience in the LVK effort. Do you think that the audience for those would engage with diving more deeply into the methodology? Do you think you'll find that you'll get this deeper penetration into the community?
Yeah, so it's a great question. So one of the things we're seeing with the online workshops, in addition, one of the types of diversity we're seeing is a diversity of engagement. And so we have folks who come in, enroll in our online course, browse through it, and then disappear and we never see them again. And we have other folks who are very keen and very enthusiastic and come in and work through everything and send follow-up questions and do, frankly, a better job with the data challenge than I would do myself. And so we see all of that. And so the answer is yes, of course, there will be some number of people who want to know about the details. But it is true that as you get, if you imagine your user community as a pyramid with, say, more expert users at the top and more, say, novice users at the bottom, it is true that as you get higher up that pyramid, you get a smaller number of people, right? So there is a constant, there is a tension between always wanting to provide more detailed and involved information and wanting to provide information that's going to be accessible to as broad an audience as possible. And what I would say is it's important to give people pathways to work through from introductory information into more complex information.
Okay, good. I think with that, we will wrap up both this particular Q&A section, but then also this this plenary session. I really like the range of topics that we've covered. It's, as I said, kind of metaphysics rather than getting into the details of how the instrument works or how to do the data analysis, what the sources are. I think it's been a really illuminating collection and one where there's a lot to learn for LISA from the experience outside. So thanks to the speakers again. Thanks to all those who participated. And we'll talk to as many of you as possible tomorrow. Bye-bye.
Thank you all very much.